Section 10.2 starts our discussion of statistics. We're going to take a look in this section about displaying data and modeling things with graphs and with numerical representations as well. We're going to start with graphs in this section. The first type of graph we're going to talk about is called a pictograph. Pictographs are really commonly used as the first kind of a description that children work with. They might do things in elementary school where they count jelly beans, and they draw a picture where they, draw a jelly bean and there's 5 red jelly beans, and then they count and they say, oh look, there's 3 blue jelly beans, and they draw 3 blue jelly beans. It's called a pictograph. So they're used really little. I mean, like pre-K kids use them. So this is a little bit different kind of an example of that, but it's the same thing. It's a pictograph. So the Automobile Club of America considers holiday weekend to start Friday at 6 and last until Monday at 6. 150 people died on such a weekend by 6 p.m. on Saturday. You're probably not going to use this at the pre-K, but it's actually straight out of your book. I didn't make it up. 150 people died on the weekend by 6 p.m. Saturday, 80 people from Saturday to Sunday, and then 100 from Sunday to Monday. We're going to draw a pictograph of the data. So, one of the things you could do, right, is that you could sort of do like a tally thing. But I don't know about you, but I don't want to do 150 tally marks. That does not sound like a space-effective kind of thing to do, right? So what we could do instead is we could actually let our pictures represent more than one, in this case, death. So morbid. So that's one of the things to keep in mind is a pictograph doesn't have to be that one item represents one item. I mean, like your picture doesn't have to represent one. So let's actually start with a couple of things. The first thing to notice and to remember about a graph is that graphs have names. So before we're all said and done, we're going to have to name our graph, give it a title. The other thing to notice is that you need to indicate any kind of scaling you do. Like, for instance, if whatever picture we decide to draw in our pictograph represents more than one, we need to actually have a key that says, little square box means 10 people or whatever. I mean, we actually have to write that down to indicate that. So let's actually start with the description of this graph. What is this going to be? Deaths. Deaths on a holiday weekend. It's a happy, fun problem. Now, the different descriptions, there's 3 different numbers that are mentioned. Let's see, we have 150 people by 6 p.m. Saturday. We have 80 people by 6 p.m. Sunday, basically. We have 100 people from Sunday to Monday. So there's 3 different types or groups of people that we've sort of considered. And so we need to have, that's why I've got these 3 lines here. I'm going to write on top of each of the 3 lines the 3 different time frames, basically. So the first one would be Saturday to Sunday. The second one is, I'm sorry, Friday to Saturday, wasn't it? Let's write that again. Friday to Saturday. Saturday to Sunday. And then there's Sunday to Monday. Pictographs are really, really simple. You're going to decide what kind of a picture you want to draw, and then you're going to redraw that picture multiple times. So what would you like to draw that I can draw, which means it has to be simple? Circles. Okay. Circles are great. We're going to draw a circle, and we have to draw it lots of times. So how much do we want our circle to represent? 20 people. Okay. Now, there's going to be one problem with I like 20 people too. There's going to be one problem with that. What's going to be the problem? Yeah, we're going to have to draw a half circle at some point. Are you okay with drawing a half circle? Yes, because it's a simple thing to draw, right? We can draw a half. When I do this on the smart board, I usually, there's a picture here that's hearts, so I usually use hearts. That's actually something that's also really easy to cut in half to draw the picture of, and since it's talking about people dying, at least makes a happier statement. It's a happier statement about it. All right, so let's see. We have 150 people. I'm sorry. 150 people. So how many how many circles do we need to draw? 7.5, right? So we're going to draw, oops, I'm not going to circle. So there's my 7.5, I'm sorry. There's my 7 of them, and then I need half another circle. One would think I could draw a half circle. I can do better in real life. On the screen's a little bit different, but yeah, so we've got 7.5 circles. The next one, let's see, we had 80 people. So how many circles should I draw for that? 4. Now, we do have to do one thing to make sense of our picture. We got to line these up, and we've got to draw them the same size. So you can't draw some circles really big and some circles really small. They have to reasonably look like they're attempting to be the same size. And so then we're going to draw the 4 right underneath the first 4. Or at least reasonably so. And the last one's 100 people, so how many would that be? That's 5. Again, lining them up as best as we can to make them reasonably accurate. Okay, so this is a pictograph of this data. People who died on the holiday weekend. At least avoid the roads from Friday to Saturday, right? All right, any questions on a pictograph? You guys have seen these before, right? Okay, yeah, they will use them. Even my son uses them in the pre-K, so pre-K and kindergarten. All right, this next one is almost like a pictograph, but it almost looks like it's turned on its side. So this is called a dot plot or a line plot. It's a quick and simple way to display data with fewer than 50 values. So if you've got more than 50 values, you want to use this, and you'll see very quickly why here in a minute. These are the mass in kilograms of each child in Mrs. Good's class. So these are all different numbers here, and we're going to make a dot plot, otherwise known as a line plot for this. So what we're going to do is we're going to draw a line down here, and the line is going to represent, kind of like a line would represent an x-axis in a graph, an xy plane, or a number line, if you want to think about it that way. And what we need to do is look at our data and actually figure out what's the smallest number and what's the largest number so we can make our accurate picture down here. What is the smallest? 39? There's a couple of them. And the largest? 49? All right. So as you're looking at your axis down here, or this line down here, we're going to start with 39 and we're going to end with 49. And they need to be at least roughly equally spaced. All right? So if we do 39 here, 40, and you don't necessarily have to label every single one of them if the graph's a little bit too small. This one shouldn't be too bad, but you could put the hash marks and only label every 5th one or something like that if you were doing something that was a little bit too compact on the line. And then what you do is you go back up to the data and you take them one at a time and you make an X. We're going to see if I can make an X that looks reasonably good. The answer is probably no, I can't. It won't even let me make one. All right, so the first value, okay, I'm not going to do it that way. We're going to figure it out. First value is listed as 40, right? So what we do is we go where the 40 is along our sort of number line, and we make an X above the 40. The next one's 42, and we do the same thing. So we go over to 42, and we make an X about the same height at about the same size. Next one's 49. So we come over here to 49 and do the same thing. 41. 43. And then finally we get one that repeats, 42. So when we get to the 42, that's the 6th one here, we stack that on top of the other 42. So we're going to stack the X's on top of themselves, for however many they need to be stacked up. Again, you have to keep remembering that these need to be lined up fairly well so that when I look at this, it doesn't look like some X is really large and some X is really small, or some height, represents something bigger than what it really is. All right, so we're going to go through all this list. So 48, 39, 46, 41, 42, 40, 49, 45, 39, 43, 47, 44, 49, and 42. Okay, so when you look at this, you should be able to look at it and say, at a glance, I mean, yeah, the most of them are in 42. I mean, I shouldn't even have to count anything. I should just be able to see it. The reason this is sometimes called a dot plot is that sometimes you won't see that a little X is used, you'll see dots. And that's okay. I like the X's just because they have a little bit bigger print. You can see them more clearly than putting dots. And I can make my X's slightly different in size, and they still look roughly the same size. If you make your dots too much different in size, they really look different. You have to be more careful to line them up. So I like the X's. There's something missing. Close. A title, right? So we don't have any labels on this one like we had. Like on the last one, we had this label down here at the bottom that a circle was equal to 20. Is that what you guys said? I heard label. Did you say title?
Yeah.
Oh, I'm sorry, Morgan. So on this one, we had this little label at the bottom that the circle was equal to 20. Over here, the X's are all actually equal to one child's weight. So we don't have to worry with a label. But we do have to write a title. Yes, so what is this? What is this a graph of? The mass in kilograms, we do need to make sure we write that it's in kilograms because we don't always measure it that way, right? There's more than one way to measure. Mass in kilograms of Mrs. Good's, we'll say students. Mrs. Good was actually my daughter's pre-K teacher. Isn't that a nice name? That's a good name to have. Does this make sense? It's okay? All right, stem and leaf plot. This is one of my favorites. This is akin. That means it's like the dot plot, but it's drawn vertically. The numbers on the left are called stems, and the numbers on the right are called leaves. All right, so these are the grades from a first exam. This actually was an exam I gave ages ago now. What's the largest one, just so that we get a reference point? 94? Does anybody see anything bigger? Not on this one. How about the next one's got 100 in it, yeah. What about the smallest? 36. Yes, indeed. This was an elementary math 2 class, by the way. This is the first exam. This was before redos happened. So everybody take a deep breath and say thank you for the redos, Dr. Hands. All right, so the way the stem and leaf plot is done is you draw a vertical line, and you use, in this case, typically stem and leaf plots are done for 2-digit numbers, okay? So the tens place is the stem, which is on the left, and the ones place is the leaves, and I'll show you how we put those in that are on the right. I'm going to do this with the largest number at top and the smallest number on bottom, although I've taught it the other way before as well. I think it kind of makes more sense in our minds on how we think of this particular topic. You know, high grades should be higher on a list than the low grades kind of thing. But it doesn't make any difference. If you flip this upside down, it's okay. So that means that I would have a 9 on top, 8, 7, 6, 5, 4, and 3. And we have to represent everything in between. So like, let's say, for instance, and I think we don't have any 60-somethings on this particular display, do we? But we still have a 6 listed here, right? Because if we left it out, it would sort of look like something's happening that's not. I mean, I want to show that there's nothing there. I want to be able to see, looking at it, there weren't any 60s. So I need to represent that 6 with nothing on the right. All right, so here's how you do the right-hand side. You go one by one through your list, kind of like we did in the last problems, and we're going to include them. So we've got 87. So on the stem that has the 8, I put a 7 in the leaf column. And we're going to rewrite this one more time too, so you don't have to worry too much about being things lined up or clean or anything like that here. 76 is next, so on the 7 I write a 6. 94, 58, 82, 43, 89, 53, 36, 80, 90, 94, 74, 77, 87, 74, 89, and 90. So this is sort of the first draft. What we still need to do, though, is we're going to put those leaves in order. Okay, so instead of it listing as 4040 in the 9 row right there, we're going to actually write 0044. Okay, so one more of these, same stems as before. And we're going to go 0044. All right, so in the 80s column, what's first? 0, and then 2. Okay, now as you're writing this last diagram here, you do need to make sure that they line up so that you don't have, like, we wouldn't want to do this, to give you an example. Do you see how that looks? I mean, it's already got more in it, but now it looks even longer than it really is because I've spaced them out more. You really need to line them up so that if they match top to, they're lying sort of on top of each other. So if there's 4 items, they really look like they each have 4 items. All right, and then I have 4, 4, 6, 7, 3, 8, 3, and 6. This is a stem and leaf plot for this data. What else do I need? A title. What is this? Yeah, so we can do grades, or you could write test scores because it is from an exam. I guess it actually said grades, so I'll write that too. Grades from a first exam. Okay, so now as Ashley saw, there's another set of data here. The other set of data is actually grades from a second exam, and it's actually the second exam from the same class, just so you know. 2 stem and leaf plots combined, and they show how things are different or changed over time, or changed between 2 like administrations of an exam or something like that. One will end up having the leaves drawn to the right, and one will have the leaves drawn to the left. So they'll actually sort of space out in both directions. Now, before we can do that, we actually need to figure out what the stem and leaf plot would look like for this data, because we haven't done that yet. So sort of the in-between step of this particular problem is I need to do the stem and leaf plot for this data. So that's where we're going to start. So let's take a look at this data. What is the largest value? I do have 100 this time. And the smallest? 64. Did they do better on this test? Oh, yes, they did. All right. Do you know why? Well, that might have been why. They might have studied. Do you remember what your first chapter exam was in Math 2? Do you remember what the second one was? Decimals. This particular group really did not like fractions. Apparently it was a big hang-up. I know, 10, 9, 8, 7, and 6. Actually, that's as far as we need to go on this particular set because we don't have any other data for it. But all right, so 93, 96, 98, 91, 93, 82, 92, 85, 64, 81, 86, 72, 96, 95, 100, 95, 94, 74. Now, this is not in order, right? So I'm going to actually put this in order within my other diagram so that we can see how that would look. I don't think I have space there. No. Okay. All right. So here's the way it goes. We're going to draw a double line here. I'm not sure if that gives me quite enough space. Let me move it over here. In between these 2 double lines are going to be all the stems. Okay, so I have to use all the stems from both of the data sets. So that means I need a 10 all the way down to a 3. The data set that's currently on my screen is going to be to the right because it was the second exam, so it's going to come after that. So I'm going to do this set right here. So this is 10, or 0 rather, and I need to put all this in order. So I'm going to start with a 1. What comes next? There's a 2. How many 3s do I have? 2 of them. 1 4. So 2 5s. 2 6s. And an 8. Did I get them all? Okay, good. How about the 80s line? 1, 2, 5, 6, lined up. The 70s line's already in order to 4, and the 60s was 64. So this is actually the stem and leaf plot if it didn't have that second bar sort of on the left for this particular data set. What we're going to do then is we're going to go back over here, and we're going to take this data, and we're going to put it into the other side on the right. But we have to move from the inside out. So this was 0, sorry, in the 90s column we had a 0, a 4, and a 4. So you're moving sort of outwards from the inside to write your values. So they're kind of actually going in backwards order as you read from left to right. So in the 80s column I had 027799. Then I had 4467. No 60s. I had 3, 8, 3, and 6. So this is what the back-to-back stem and leaf plot looks like. This is the first exam on the left. This is the second exam on the right. And so what do I need to write? I need to write that these are exam scores or grades from exams on a first and second exam. Now there's one more thing that we haven't written on either one of these. We actually have to say what in the world this diagram means. That is, what does the stem and the leaf represent? So I'm going to go back over here and I'll do this one first because I didn't do it on this one either. I need to know that what these numbers mean, so I don't care which one you pick. I'll just pick the 36. 3/6. Make sure that the slash is clearly not a 1. It doesn't look like 316. 3/6 is a grade of 36. And that's what we mean by it, right? So we're just identifying that in writing. So again, it doesn't even have to be in a specific location. I'm running out of space here. Let me move this up. So we'll write down the 6/4 is a grade of 64. You can use any of the data to describe it. That's fine. Any questions on that one? All right. Let me see if we want to do one more, where that puts us. Yeah, one more will put us in a good spot to stop. So we'll do one more before we pause. Grouped frequency table. What this does is it shows how many times the data occurs within a range or class of intervals. So sometimes we group things together, and grades is actually a really good example, right? Unfortunately, or fortunately, depending on your perspective, when you look at your transcript, you see letters. Agreed? So that can be great if you ended up getting lots of low 80s for it to say B. Yay! But if you had an 89, I probably end up getting an email from you asking, would you please round my grade up? Because it's so close, and there's nothing on there that says how close something is. But that's a way of doing a grouped set of information. So your transcript is actually a way of doing this, or at least it uses that kind of information. So this is the data from the second exam. We're going to use the standard grading scale, and we're going to make a grouped frequency table. All right, so here's what this looks like. We're going to have one column that's going to be our grade. And these are our, like the numerical grades, like the disparate, the way that we're setting up the grading. So currently, the way we do standard grading these days is that we have a 90 to a 100, right? We have an 80 to an 89, a 70 to a 79, and a 60 to a 69, because we already remember that the highest grade was 100 and lowest was 64 last time. That's not always how grades have been done. Did you guys know that? That's not always how they're done in other places either. When I was in elementary school, and I remember it changed at some point when I was in middle school or high school, I can't remember, it used to be that it was 93 to 100 was an A. And it was like an 85 or an 86 to a 92 was a B. I don't know why. I don't know why those numbers were picked. I have no idea. But this is what we tend to see used most everywhere now. And not everywhere, but mostly this is pretty common anyway. All right, so these are the grades. We're going to do a tally column in the middle. Tally columns are really helpful. And the last column over here is simply going to be our frequency. And all frequency column is it's the numerical value represented by the tally column. So you're just writing it as a number. All right, so what this does is this allows you to go through your table kind of like what we did when we were doing the stem and leaf plots and just make a tally when you get one of them. 93 is an A, 90, right? 96, 98, 99, I'm sorry, not 99, 91, 93, 82. Okay, so I'm just making tally marks. 92, 85, 64, 81, 86, 72, 96, 95, 100, 95, 94, 74. And then you count. So how many 90 to 100s did I have? 11. How many 80 to 89s did I have? 4. How many 70 to 79s did I have? 2. How many 60 to 69s do I have? 1. That's it. This is a group frequency table. It's that simple. You're just making a tally chart. That's all you're doing. It does need a title, though, just like all the rest of them. So what is this? You got it. Grades from the or A or whatever it is, the second exam. Simple enough? All right, we'll stop there.